All right, guys. Well, let's do some math here. So today we're going to be doing using logarithms to solve exponential equations. So you don't need to write this, but we've solved problems like this before. This is an exponential equation, and the way that we solved it was we got the bases to match and then dropped the bases off, right? But the problem is that if you come to problems where you can't get the bases to match, yeah, you're not going to be able to do it. So logarithms can help us in that situation. That's what we're learning today. Okay, so before we begin, I want to review with you guys a log rule. You do not need to write this, but if I have this, what can I do with that x? You could put it to the front, right? We're going to be using that all day today. That's our main rule. So here we go. Let's go ahead and do an actual example here. So we'll start easy and we'll work our way up. Example 1. So 18 to the, I'm just going to make problems up here. 18 to the 3x minus 1 equals 40. Okay? So the question is, what power would I have to raise 18 to get 40? Well, that's not going to be very easy to do mentally, right? So here's what we're going to do. We're going to start by logging both sides with a base of 10. Why am I choosing base 10?
Because that's just a natural number.
Because we're going to use a calculator. Which, by the way, I guess I should have told you. So come get a calculator. I'll start over. Sorry. Forgot about that. You need calculators. So now, here's how we're going to deal with this, you guys. We're going to log both sides, and we're going to use a log with a base of 10 because that's what our calculators do. So check this out. Here we go. Log on this side and log on this side. Notice I'm not writing my base there because it's a 10, right? But there it is. All right, so now, why did I do that? How does that help me? Well, I'll show you. It has to do with that little log rule I reviewed with you guys at the very beginning. When you have a log and your argument has an exponent, we could take that exponent and we can put it up to the front, right? Now, I'm putting mine in parentheses, and I think that's a nice way to show your work. I would encourage you to do the same, but technically, you can get the same answer if you don't. Okay, so now we're getting better because the issue is you can't solve for x when it's in the exponent. So this little trick allows me to get it out of the exponent. Now, the next thing I'm going to do is I'm going to divide both sides by log 18. That way, I'm starting to get x by itself, okay? So now I've got 3x minus 1 equals log of 40 over log of 18. And now what I'm going to do is I'm just going to use my calculator to get this. So let's do that. Log 40 divided by log 18, and I'm just going to go ahead and just take it out to the third decimal place, the thousands place. So let's see, log 40 divided by log 18, 1.276. After that, guys, we just get to do some basic algebra. So how do I solve for x? So that's how we're going to end up solving it.
I found the answer.
We should be getting 0.759.
Yes. This is correct.
So that's how we can use logarithms to solve exponential functions. Okay? Now I want to show you guys one more thing before I let you guys practice here. I guess we should call that problem, what, number 1 or something? For A?
Probably.
Let's call that A.
Okay, I'm gonna put in-
You go away? There it is.
No, it's number 1.
So we'll call that A. Let's do a part B here for this example.
Nope, I'm doing a 2.
So here we go. Oops.
Mistype. Let me see. I will continue the height until I know.
Closer. Now this is how it's going to look on your homework too. This is not 5.3, okay? This is 5 times 3. 5 times 3.
Thank you. That felt good.
Okay, so here's the deal with this problem here. Here's our little thing that we had on the last problem, right? We have a base with a power, but these other two numbers, that -8 and 5, we need to get rid of those before we do anything else. Oh, do you want to tell me what to do? So what would you do? Yes, so the first thing you're going to do is you're going to add the 8 to both sides. So let's do that. Remember, that's not 5.3, that's 5 times 3, and I'm writing it like that because that's what it's going to look like on your homework. Okay, now I think the tempting thing for you guys here might be to multiply that 5 and 3 and get 15, but you can't do that because that 3 has a power on it. So what would you have us to do? There you go, so you just divide. So that's it. Well, after you do those two things, the rest of the problem is very much like what we did already. So we have 3 to the 2x plus 3, and that's going to go in there, what, 9 times with 3 left over, 9.6? Someone want to double check me on that?
Yeah, you're right.
Cool.
Bailey, you're scared.
All right. So now I'm going to let you guys walk me through this a little bit. Let me grab my cards.
I just told you.
Okay. So I'm going to ask Ishmael, huh? Sophia? We're going to log both sides. Okay. Next person I shall come to will be Giovanni Ramos. What's next? So we're going to take that exponent, we're going to put it in the front. Good. Seth, what's next?
You want to get rid of the log 3?
Good. We divide it to get rid of the log 3, right?
I think that's right. I think that's how I'm supposed to do that. I'll find out when Bailey gets to where I am. I'm kind of ahead of you.
Okay.
Have to hide from the
So we're going to use our calculator for the rest of that there. Dylan, did you get that yet, Bryant? No? I'm going to go to this Dylan who's there, got it.
Yeah, I got the answer. I got
Just for the decimal, right?
decimal?
Yeah.
2.059.
5.9?
Yeah.
Okay. And then from there, guys, I think we all know what to do. You're just going to solve the equation, right?
X equals -0.530.
This one, is that the final answer or is that this next step?
Oh, no, that was the final answer.
Okay.
The next step one is -1.059.
Like that?
Yes.
I don't know about that.
I got 0.941.
No, you get negative 0.941.
Negative 0.941?
Yes, sir.
Yeah, I agree with that.
Still got that answers.
All right. Hassan, what's up now? Oh, well, I guess it's kind of obvious, but go ahead. Sorry, I didn't mean to insult you there with asking you to do that problem, but there you go. So basically, we're just going to divide, and now we're getting a final answer of.
Negative 0.4706.
So I'm going to say 0.7. Okay, guys, so there you have it. I'm going to throw 2 of these problems at you here. We'll see what you guys can do. Student practice number 7.
I thought it was 80.
Who did that?
I thought it was 1,000.
1. All right.
2.
Don't take advantage
No,
of
it's
me.
90.
I'm fragile.
You guys are wrong.
12 to the x equals 100.
You don't learn anything in this.
Go ahead. That's for you guys. So there's your answer for number 2. Answer for number 1 was 1.853. That's the basic idea. I want to talk about 2 little details here.
X equals 7.97, and I just added 0 at the end of that. Cool.
Okay, here we go. I don't think we need to be that specific. E to the x equals 40.
Wow,
I'll write that one down. All right, guys. So what do you think? What are we going to do now? Good. So check this out. We can ln both sides, okay? That's fine. Actually, we could have been doing that anyway with the other problems. You could have been ln'ing both sides of the other problems also because there's an ln button on your calculator. I'm just choosing to use log. So we can use ln, but the reason why I'm assuming that Talia said use ln is because there's an e here. And that actually makes things a little bit easier. Check it out. If you ln both sides, we don't need to do that whole step. You don't need to do that step where you put the x in the front and then divide. You know why? This is one of our old log properties. Those just cancel each other out. And there's your answer. So that's different because the bases match, right? With all the other problems we're doing, the bases haven't matched. I've been using a log base 10, and the number that was in there wasn't the same. So I had to use that property where I put the exponent in front. But in this case, this log has a base of e, this is a base of e, and so they just cancel each other out. The same thing applies for 10. If you have a 10 and you do log base 10, you could really just cross it off. You don't need to do the little division thing. Okay? You could also do this like this if you wanted to. You wouldn't be wrong. You could log both sides with a base of 10. It would work. You would just have to go about it the other way where you put the exponent in front and then divide. It is extra, and it would work, but it's more work. So if you have an e, my advice would be just to use ln. Here's another thing. Let's go ahead and take a look at part B. Write that one down. So I'm going to have you guys walk me through this one, okay? Here we go. So I'm going to be asking Isabella, what do I do first? Divide by -2. CC, what am I going to do next? Oh, you haven't been here, but what were you saying? No, but that's not a bad answer. I'll still give you a point, but you've missed, so check this next step out. This is kind of the important one for today. Jermaine, what's next? You log both sides. It doesn't matter which one you do. You could do log base E. Okay. Alex, now what? X minus 4 to the front? Good. Tristan, what's next? Divide by log 6. Okay, go ahead and do that in your calculators for me. What if I don't want you to not want to solve this?
Well, then I don't want to.
What if I just stop caring?
Sure, I don't solve it for you.
What if I care about your not caring?
Well, that just sounds like you probably.
Oh.
Well, then
Good
I
answer.
just don't do work.
What do you guys think?
Pretty simple.
I got an error.
Good. You should have gotten error. Now
it has a negative.
Yes. So now you guys can catch this in advance. Remember, what you plug into a log has to be a positive number. So way up here at the beginning, you guys may have been able to just notice, oh, well, if this is negative, this is positive. After I divide, that's going to be negative. I'm not going to be able to log that. There's no solution. So you can catch it if you can. If not, just go through it, and your calculator will tell you that doesn't work, and you just put no solution, okay? So those are some things to watch out for. Last thing I want to do with you guys before we call it a day is I want to look at some word problems.
You said
Okay,
word.
Ron.
No!
You guys love word problems.
No, I don't!
Dylan. Dude, you told me, like, Mr. Bailey, if a word problem could become a person, I would marry it. Those are your words.
It's really a word. I hate this thing. I hate this thing.
My words are...
All right, so this is why I printed this little half sheet out for you guys today, so you don't have to copy the whole problem down, okay? But something you might want to copy down is the following. We talked about 3 exponential formulas, okay? We talked about the general one. Oop, I've lost my palette, just a moment.
So do we just have to solve all of these?
Here's the general one. You have your starting amount. If it's increasing, it's plus. If it's increasing, it's plus. If it's decreasing, it's negative. R is your rate at which it's increasing. That's your growth rate. Remember that stuff from back in the last chapter, hopefully? That's your general exponential function formula. We talked about 2 special ones, though. Compound interest was another one that we talked about. Compound interest. I'll get to all of them. Yeah, I'll get there. All right. So for this one, it's almost the same exact thing. It's just that your rate is being divided by how often it's compounded per year. Oops, that's not right.
I'm not happy with you, Bailey.
That's our compound interest formula. And then finally, we talked about another one, which is compound continuous problems. Problems that are compounded continuously. And that's the one you were talking about there, CC. It looks like this. A times e to the RT equals y. And the r could be plus or minus. I want to redo that minus there. It looks weird. There we go. Remember, r is positive if it's increasing. R is negative if it's decreasing. So those are our 3 formulas. How do you know when to use each formula? Well, if the problem's talking about money being compounded, then it's probably this one. But if you see the word continuous in there or continuously, it's the bottom one. If you don't see either one of those key words, then it's just a general exponential function. So let's read the problem. In 1980, the population of Mexico is 67 million people. Since then, the population increased by 2.5% per year. How long will it take the population to reach 70 million? Kaylin, general, compound interest, or compound continuously? Which one? It is general, because I don't see either of those other keywords there. So this is our formula we're going with. Now let's find these things. So it's coming at you guys kind of cold here. So Dylan Smith, what does the A represent in these problems? Do you remember?
So A represents the amount of growth, so like the 67 million people.
It's the starting amount of people. So what is the A value in this word problem?
67.
Good. So I'm going to draw an arrow to that. So my A is 67. Ricardo, what does the R represent? Which in this case is what? 2.5. Good. Now you guys got to remember we have to change that to a decimal, right?
Yes, sir.
Austin, plus or minus?
Plus.
Because why? We have an increasing function. Good. Now there's another number here, and this is new because we didn't have this last time we did these problems. It's the 70. So where does that go? The 70 is your final amount, and that goes in where your y is at. That's right. Our goal is we want to find x. X represents how long it takes for that to happen. Okay? So let's go ahead and fill this out. We have 67, 1 plus, what is this in decimals? If you forgot, on your calculator, do 2.5 divided by 100.
0.025.
It is 0.025. And over here is a 70, right? So I'm going to go ahead and simplify this. Now, can we solve for x? What would you do first if you wanted to solve for x? Divide both sides by 67, right? And then you would log both sides. I think you guys can handle that. I don't want to dwell on that too much. I just want to make sure you guys know how to set it up. Okay? So, can I...
Wait.
I want you guys to read it and pick your formula. I'll give you a few. You guys see the word compound in here?
No.
Do you see the word continuous?
No.
Okay, so it's general again, Alan. All right. Now, I want you guys to fill in the blanks here for me. Fill in all the letters that you can. Go. Fill in. At least with that I could... Oh, you got a point anyway. Because it was a good answer. It wasn't right, but you gave good participation.
Legit.
Diana, what goes here? Starting amount is 200.
And she's like, no, so you go on it. I have no comment on the matter.
Carlos, plus or minus?
In my head, I'm thinking it's completely right.
Good, because it's a decaying problem. Taekwon,
Wait.
what goes here?
Wait.
0.115. Good. Kevin, last number?
Wait a minute.
Now, we got to subtract these, so that's going to be 200 times, I don't know, 88.885?
Yeah,
Like that? All right. Okay. From there,
Same thing.
what would we do?
Divide by 200.
Divide by 200, then we would log both sides, and we'd be home free. Okay?
Say. All right. No homework. You guys are too smart. We can go have a
Mr. Bailey. No. I see your look, Mr. Bailey. Mr. Bailey.
All right. I'd like you guys to try this one, please. All on your own. And I actually want you to solve it. Take it all the way home for me. Go for it.